Welcome to This Explainer. Today, we are unpacking a truly fascinating analysis of how we consume energy and, more importantly, how artificial intelligence and smart design are literally rewriting the rules of the grid. So if you care about efficiency, sustainability, or just the massive, invisible systems that keep our modern lives running, well, let's dive right in.
I want to start things off by asking a highly relatable question. How many of you switched on a light this morning? Right? I'm guessing pretty much everyone is nodding right now. We interact with electricity every single day. It's just second nature. But here's the kicker. Almost no one actually knows how much electricity their house consumed yesterday.
The contrast in our daily lives is honestly kind of absurd. On the one hand, we know our phone battery percentage every single minute. If it drops to 20%, total panic sets in. But our home electricity, we have absolutely zero idea where it all goes. It's the one thing we consistently pay for every month without really understanding what we actually used. It's just this massive blind spot for most of us.
Which brings us to part one, the invisible energy drain.
We can actually see this huge blind spot play out on a macro level when we look at unprecedented infrastructure growth, especially in places like India. Think about it. Every new hotel, shopping mall, hospital, metro station, data center, school, and dairy processing plant, they all need massive amounts of energy to function. With development happening at this crazy scale, the question really isn't just, can we produce enough energy anymore? The real question we have to ask is, can we intelligently manage the energy we already have?
And that leads us to a core philosophy for this whole topic. The cheapest unit of electricity is the one we never add to consume. It's so true, right? True efficiency doesn't start with just building more and more power plants. It absolutely starts with preventing waste in the very first place.
Up next, Section 2, the idle accelerator problem.
Think about how wildly different buildings behave. A hospital operates 24 hours a day, non-stop. A shopping mall mostly packed during evenings and weekends. A theater gets massive energy spikes right before every movie starts, while schools are practically empty during holidays. A dairy plant might use enormous amounts of cooling energy, but only during specific production runs. Every single building is entirely different. And yet, so many of them are operated in the exact same inefficient way. Lights stay on, air conditioning blasts in completely empty rooms just because, well, that's how we've always done it. Imagine driving a car with your foot fully pressed on the accelerator while you're just sitting there waiting at a red light. That is exactly how absurd it is, and literally what so many of our buildings are doing every single day.
So, how do we fix it? Let's get into Section 3, how AI sees energy.
This is where the tech becomes truly exciting. Now, we aren't talking about AI replacing human engineers here. We're talking about an incredible system that notices complex patterns that humans simply cannot see. Imagine millions of sensor readings happening simultaneously. We're talking temperatures, weather forecasts, occupancy levels, real-time power consumption, equipment health, and even fluctuating electricity tariffs. AI takes all of these random puzzle pieces and connects them together to make perfect sense of a building's entire energy footprint.
It takes this massive wave of overwhelming data and simplifies it into actionable steps. Step 1. It predicts tomorrow's energy demand based on the weather and schedules. Step 2. It detects equipment failures before they even happen, which saves major downtime. And Step 3. It recommends better operating strategies. Sometimes, the absolute smartest innovation is just operating our existing equipment more intelligently. You can literally save massive amounts of power without installing a single new machine.
Let's shift gears slightly for Section 4, design thinking in energy. Managing resources isn't just about artificial intelligence. It's also about how we frame our problems as humans. The standard engineering approach usually asks, okay, how can this machine consume less energy? But design thinking, it asks a much better question. Why does this machine need to work this hard in the first place? Reframing it like this completely shifts our focus to the root cause of the energy drain rather than just treating the symptom.
And that leads to some brilliant design questions, like, can daylight replace artificial lighting? By simply designing a space with better windows and smarter orientation, we can completely eliminate the need for hundreds of light bulbs burning all day long.
Or consider this one. Can buildings be designed to remain cooler naturally? Through some clever architectural foresight, using specific materials, proper shading, and natural airflow, we can passively reduce our reliance on heavy, power-hungry air conditioning systems. And finally, can waste heat from one system become useful energy for another? By asking these kinds of questions, we quickly see that the biggest energy savings don't always come from better technology.
A lot of the time, they come from better thinking. Which brings us to our final section, India's smart energy future.
This is truly one of the largest opportunities for energy efficiency anywhere in the world. We are talking about thousands of commercial buildings, millions of homes, and one of the fastest growing data center markets globally. Now, the irony here is that as AI grows, those data centers are going to consume more electricity than ever before, so upgrading intelligent energy management, improving cooling systems, enhancing server utilization, and seamlessly integrating renewables, it isn't just good engineering anymore. It is absolutely critical national infrastructure. Every single percentage of improvement matters for cost, for sustainability, and for our overall resilience.
The future is built by making every unit of electricity count. And I really want to emphasize that the ultimate goal of energy management isn't asking people to sacrifice and use less. Not at all. It is about empowering every single building, machine, and system to use its energy wisely. We aren't just blindly producing more. We are optimizing exactly what we already have.
Because at the end of the day, the smartest building is not the one with the most technology randomly packed into its walls. The smartest building is the one that makes the best decisions. And that future, it belongs to the engineers, the designers, the building managers, students, and honestly, every single one of us collaborating together.
Which leaves us with one final, incredibly important question to consider. What invisible energy drain can you fix in your world today? Whether it's advocating for smarter systems at your workplace or simply taking your foot off that idle accelerator in your own home, you have the power to make a real change. Thanks so much for joining me to explore this explainer today. Keep learning, keep questioning, and hey, let's go build a smarter future together.